Hey guys, welcome back to the Zenith Portal Television Restoration Project. Last installment did a video IF alignment using a spectrum analyzer and got a really outstanding sharp image, very good frequency response. I've got the chassis on its side right now because I'm about to start tinkering with it a bit more. Right now I have that multi-burst pattern up that I showed in the previous segment, which shows you how good the bandwidth is in chunks. And we've got definition all the way out here to 4.5, and thinking, hey, it's super sharp, it's awesome, except for one thing. Not supposed to actually have quite that much video bandwidth, even for one of these early sets. It should be more like 4.2, 4.1, something like that, because the sound carrier is at 4.5. We haven't talked about sound yet. I do have a speaker hooked up now. Do we have sound? No, but if I tweak the fine-tuning, I can get sound. Now, this is a split carrier set, so right after the tuner, the signal goes into two paths. This is the audio path, and we have not aligned this yet. We have the video, which is on the opposite side of the chassis. But if I tweak the fine-tuning, we can get sound. However, there's a little bit of a problem. Yeah, you're not supposed to get sound bleeding into the video like that. So there's two potential problems. One, the sound IF could simply be off frequency. Two, there is a 4.5 megahertz trap. Somebody asked about this in the comments. So I think it's between the first and second video amp stage, something like that. There's a very sharp, distinct trap. Capacitor and inductor in parallel, so it's tuned to 4.5 to completely eliminate any possibility of sound getting into the video. Obviously we do, and that's very bad, and this is what happens. It makes kind of an insane pattern if I change the frequency of the sound with my test pattern generator. That's 300 hertz, so 1 kilohertz, and 3 kilohertz and 5 kilohertz. So that's not good, and if we turn off the sound, we're back to our great looking picture. Now, if all you cared about was video and you weren't going to do sound at all, cool, you could call it done. But I do want to have functioning sound with a good picture, so we're going to go through it. Now, I am going to do the sound alignment and do the overall video alignment using a conventional sweep generator rather than the spectrum analyzer. One, I want to double check my work. Two, I'm curious to see how it goes using the built-in scope jack. And also, this sweep generator has 5 programmable markers. And in particular, I want to see this response curve with all 5 markers at once. Now, I tried doing that a little bit with the scope in XY mode. I wasn't able to see the markers, which should show up as bright dots on the response curve. Thought maybe there was something up with this scope. There is a output on the back of the sweep generator that's supposed to put out, or does put out, a pulse at the marker position, and I connected it to the intensity modulation of this scope. However, looked at the specs, and the polarity and the voltage levels that this puts out aren't really compatible with this scope. I tried using an older 465 scope, and I could just barely make them out. Now, it is possible to open this up and adjust that marker output voltage level. I dug through the service manual and found it. It's not trivial to do. I'm not going to do it. However, there's something else you can do. I hadn't thought about it, or hadn't occurred to me until I took a look at what does that marker signal actually look like. I thought it was just going to be like a little square wave, rectangular pulse wave. No, it's not. It's actually a burst of 5 kilohertz triangle wave. It might help explain what I'm talking about to show you what the waveforms look like. Bottom trace is the sweep output. It's a ramp. So this would be the lowest frequency and the highest frequency. This is what's driving the x-axis and pushing it along as we sweep from one frequency to the other. The upper trace is the intensity marker output. So I right now have 3 markers programmed, and these are the 3 points. Now, instead of looking at it like this, when it's in XY mode, This ramp drives the x-axis, and these blips here are supposed to go to the intensity modulation and put a bright dot on that line as it's going from left to right. It's not working with this scope, I think, because these voltage levels are not what it wants. Let's isolate it and just look at those and see if we can figure out what the voltage is on them. Oh, interesting. I just assumed that was a spike. It looks like it's a little burst of a sine wave kind of thing there. Well, that's 1 volts per division. So, let's see, is this... Okay, that's ground in the center there. So it's going plus minus 1 volt. The back of this is its TTL, so I think it wants more like 0 to 3.5, 4 volts, 5 volts, something like that. And this is only doing about 1 volt. Yeah, just a little more than 1 volt. So I think it's not, doesn't have enough amplitude to do the intensity modulation. Okay, so what can we do with that? Well, the service manual for this as well, what you can do with it is take the output from the back of this with that triangle marker and fit it into the modulation input and enable AM modulation on this and make more traditional birdie markers, which are like little weird fluttery things where the markers are. So I've got this rigged up so we can see that. Sort of. It'll work a lot better when we actually have a device under test, but this is enough that we should be able to see them. And sure enough, there they are. So this thing down the middle here, that is my output of my sweep generator. And notice the amplitude increases going to the right. It shouldn't be. I don't know if that's something up with the automatic leveling control in the sweep generator, or the scope, or the way it's terminated, or whatever. It shouldn't be that big a deal for the alignment, but ideally that should be perfectly flat across. Anyways, these bump outs here, those are the birdie markers. So can I make that a little bit? Trying to zoom in here so you guys can see one closer up. So that's it right there. I can also just hold down the button for a marker and you get that, but it's nice to get this. And those distinct striations, that's, as I've mentioned before, this is a digital sweep generator. It goes in discrete steps, it's not continuous, so you have gaps in the frequency coverage. But it should be good enough for our purposes. Now if I ran this through a detector probe, instead of seeing these lines and all that, we'd see a flat line and we should see a little squiggle where the markers are. So we'll get to that when we inject this into the TV and put our scope after the detector in here. It should make a lot more sense, but I wanted to show you what the raw signals we're dealing with look like, and that there's more than one way to show a marker. If intensity modulation doesn't work, you can feed this back into itself and do AM modulation with the marker. Alrighty, now the moment we've all been waiting for, the overall response curve. It should look something like that. So now I am injecting into the mixer tube using an ungrounded shield over the mixer tube. And there we go. So in this case I am using this as a sweep generator. I have 5 markers programmed in at the 5 frequencies shown on the diagram, and it's pretty darn close. The goal is to get it as flat as a response as we can between 22.2 and 25.1, which are these 2 markers there and there, and it's a slight dip in the middle, but that's pretty darn good, I think. I also learned a little bit more about this device and the sweep. So as I mentioned before, it's discrete. You can do it in steps. If you do linear, 100 steps, looks like that. Get a bit of a gap between the dots. You can do 1,000 steps, which is a lot smoother, but a much lower refresh rate, kind of harder to see. What I didn't know you could do is set size, which is programmable of how much it goes with each step. And that's what we were looking at to start out with. I chose 0.05, so that comes out to about 200 steps or something like that. So it's a compromise between these two. There's also a log, which I don't quite understand. If you do log 10%, you basically just see the markers, which is kind of odd. And if you do log 1%, you get something like that. Alrighty. And yeah, using the markers, but taking the marker output and doing AM modulation inputs. I got 25% AM mod. We can see the markers on there pretty distinctly. So I think we're pretty well set with the video IF. Now let's tackle the sound, which they show on this side. Let's see, the instructions are on this side, but the waveforms are on the other side. So we want to get that typical looking FM demodulator S-curve, and there is the sound response. So since we have such strong sound interference coming into the video, you get 2 possible ways that could happen. One, the sound is not centered on 21.3 like it should be, or the 5 megahertz trap is off. My money's on this because when I tune it in to get a clear tone, the video looks crummy. It's not just interference, it's not where the optimal video is. Ideally, you get the best sound at the best video. So let's do the sound IF next, which is these 4 cans up here. Before I get into aligning the sound, I want to go over the sound circuitry, which is a lot easier to do if I rotate the chassis 180 from where I had been working on it. So previously, you'd seen it always with this transformer side down. Now it's flipped the other way, and the sound is down here. While reviewing it, I realized something. One, I missed one bumblebee cap, but also that guy and that guy, they look like mica caps, right? Pretty darn sure they're not. What they are 0.0012 microfarad caps. For whatever reason, Zenith, for the first few years of these porthole sets, always used kind of an oddball value in the sound circuit. But what I'm used to seeing is them being in bumblebee format. These are not, but I'm pretty sure they're just paper caps hiding inside of Bakelite housing. I am going to replace them with these guys. And I've been double checking resistors, and some of them are out of spec. For example, there were a couple of these big old 6.8K 2 watters that have drifted pretty far out of tolerance, so I'm working on replacing those. And I'm going to check the rest of these resistors. Once that is done, we will do the sound alignment. I finished up work recapping the sound circuit, flipped the chassis around again, so now the sound is up on top, and I'm starting the alignment process. I've got my signal injected at the final stage, and my scope connected after the ratio detector. We're supposed to get the good old classic FM curve like so, centered at 21.3. I have the 3 markers programmed into my generator, and here we go. So there's the first marker, 21.1, which should be at the peak, and it is, but the crossover point should be right in the middle, the second one, and it's up here. It should be more like there, and the peak here is definitely wrong. It should be, or the peak on the bottom rather should be shifted over to the left, so we have a little bit of work to do on that. These coils are a little bit tricky because there are 2 slugs, but you access both of them from the top using a hex plastic alignment tool. Let me grab one and see what we can do. So I'm injecting into this tube right here and sensing on the other side of it, and then we're going to work our way back. But right off the bat, we know we have some issues, so I'm hoping that this will take care of my sound interference problem. On the 2 stages before this, we're going to get more of just like you do more like an AM radio. We're going to peak just at 21.3. Now the last thing we're going to do is the trap alignment, where we want to block that sound from getting into the video. This is the kind of tool we need. Plastic with hexagonal shape on the end. We go into the top, carefully feel around and get the top slug, and adjust that. Boy, that certainly has a very distinct effect on the waveform. Let's get that about there. Now if I continue to insert it, feel around, there's the bottom, oh, there's the bottom slug. Okay, adjusting that also affects things. Now I need to go around back and forth between the two to get that crossover point right in the middle and get the peaks where they're supposed to be. I think this is going to take a little bit of doing. So it shifts the whole thing very obviously left to right. So now my crossover is right in the middle, but that peak on the right, or the trough rather, is not quite where it's supposed to be. Well, I will keep at it. I'll get it eventually. The key thing though is to get the crossover right in the middle. The peaks aren't on the edges aren't quite as critical. I'd say that's better. I did increase the delta frequency from 1 to 1.25 so I could see a little more of the overall response. I've got the peaks pretty well where they're supposed to be, and it's crossing over in the center, so we can proceed to the earlier stages now. Okay, now we're getting to what I really wanted to see, which was the IF response, and sure enough it's way off. So again, 21.3 is in the middle. We are peaking way over here, and then you shift it over to the left. Just like with the other alignment steps, they make things convenient for you. For this stage, you clip the scope right to this access point here. For the earlier step, I was clipping to this point over here. So you can almost do it all from the top of the chassis, except you need to inject the signals on the bottom of the chassis. So maybe they had a test jig so they could do injection from the top at the factory. I'm not quite sure, but anyways, at least there are some conveniences they added. Alrighty, so again, with our hex tool, now we're doing this can. We want to move that over to the left. And, oh, my luck just ran out a bit. The good old dreaded frozen core. It doesn't want to move, at least the top one doesn't. Let's see about the bottom one. Okay, the bottom one I can move. I may go up and down, but I need to make it move over to the left. I really got to move that top slug. So what can I do? I will try squirting a little bit of fader lube into that. WD-40 you could also try. You want to use something that's not going to hurt anything, but you also don't want to force it. You don't want to crack that slug. You're going to have a very bad day. So let's just give this a little squirt. And we're going to wait a little bit. Hopefully that will loosen things up. Alright, yeah, I'll let that sit a little bit longer. And I will go back and forth and gingerly try to free it up. I definitely want to be able to adjust that because I suspect this is the heart of our problem here. Alright, it's been a couple minutes. Let's give it another try. Oh, yes. Fantastic. It's moving. Slide it over. Let's check the other core. Peek it. Alright, that is much better. I finished going through the remaining sound IF stages. They were also off a little bit. Finished tweaking them. Have a speaker hooked back up to the sound output. Did not adjust the trap yet. I wanted to see where things were at as is. Now, before, when I turned on sound and we had a good image, I got those horrible sound bars. So 300 hertz again. Let's turn the volume up. We have volume control, but we have sound without the interference on the screen. And now when I tune off to get the interference on the screen, there's no sound coming out of the speaker, so that is a big improvement. Let's try 1 kilohertz test tone, a little bit easier to hear. Oh yeah, much better. So nice sharp image, good clear sound. 3 kilohertz, 1 kilohertz, 5. Excellent. I honestly don't think I need to even bother adjusting the sound trap. You can see how finicky these are. I'm just barely touching that fine-tuning control. You just go off to either side and you start losing the sound. And that is the downside to a split carrier set. Later sets, they put everything through one IF and split the sound off at the video amp. Alrighty, cool. So I think we're pretty close to having this wrapped up. I'm going to put the chassis back right side up and adjust the screen geometry again. Remember that shadow down there is because of the finicky focus magnet that likes to move around on me. Very nice. Alright, that's enough for now. Wraps up the alignment. I think the next installment will be the final one, which will be reassembly and taking a final look at it all back together and working. And oh yes, I need to replace the broken dial cords. Both the contrasting and fine-tuning are broken.